Muon catalyzed fusion is a hypothetical type of cold fusion. So let's start from the beginning. You'd start with a deuterium and a tritium atom. Then you'd covalently bond them using one electron, or a couple more. Now you'd replace one of these electrons with a muon, which is a cousin or a flavor of an electron, but 267 times as massive and 267 times as electrically charged. Now what this would do is it would slowly pull the two atomic nuclei together up until they were fused, and they overcame their electrostatic repulsion due to the fact that the force of the attraction from the muon was greater than the electrostatic repulsion between the two nuclei. Now, talking about charges here, this kind of helps us understand why deuterium-tritium fusion is the best candidate for fusion. This is because deuterium and tritium have the best ratio of neutrons to protons. They have 2 neutrons, 1 proton, or 1 neutron, 1 proton. This is very rare in stable and low atomic number elements, which is why it's so advantageous to have this type of an atom, as it would decrease the amount of electrostatic repulsion between the atomic nuclei. Now, as I was saying, the muons would pull together the atoms so they would fuse, but there are a couple of problems with this. One, muon's lifetime is only 2.2 microseconds. This is an extremely tiny amount of time. This could, however, be fixed using the theory of relativity. The theory of relativity predicts that the faster something goes, the slower time goes around it. And it is proven that the faster a decaying molecule or atom moves, the slower that it decays. Thus, if you accelerate the particles and the entire molecule as it was fusing, it is possible that the muon would last long enough to cause the cold fusion. Another possible problem with this is that the energy levels to create a muon are tremendous. This could be solved by the fact that muons are actually created in cosmic level events and are probably passing through you right about now in cosmic rays. Supernovas, the Big Bang, all these grand scale cosmic level events produce tons of energy and cosmic rays, which include tons of fundamental particles, including muons. These muons and other particles like them could be utilized to produce cold fusion.